Greetings, calculus. Back to my wood shop for another video lesson on how to find the area between curves. So here we are. We're going to find the area between curves. This is part 2. I'm going to call it the y-axis switch. So we're going to pull a little switcheroo in a second, and you're going to see why. And I hope that it makes perfect sense. If you're not really picking up on a lot of these, then I'm going to say shame on you because no one's reaching out to me. So again, office hours, Monday, Wednesdays, and Fridays, 9 o'clock until 10 o'clock. Click the link on the Google Classroom stream, or it should also be on your Google calendars because, folks, all of the meets are on your Google calendars. All you have to do is open up that calendar and you should see it. And if you have an iPhone, anything that goes to your Google Calendar should show up on your iPhone too, so you can get notifications on your iPhone through the calendar app there, because everything that we get at school, whenever I do meets, whenever Mrs. Potts sends me stuff about meetings at school, via the Google Calendar, it goes to my phone. So all I have to do is click accept and boom, it's there. I'm not exactly sure how to make it happen if you have a Samsung, but you know what? Just go buy an iPhone, they're better anyway. So anyway, let's take a look at calculus here. Area between curves, a y-axis switch. Find the area between y equals x minus 1 and y squared equals 2x plus 6. Oh my gosh, look at that. This problem, they said y squared. Why would they do that? Why would they do that? I don't know why, but all we have to do is do this. Y equals plus or minus square root. All you gotta do is square root it. Look at that. Problem solved. Okay, so first step in any area problem, what do we have to do? Graph it. So get out your Inspire, start graphing this sucker. All right, so let's graph this thing. So the first thing I'm going to graph is x minus 1, and that's easy peasy. You know, you know how to graph y equals x minus 1 back in, what was it, probably 7th or 8th grade, maybe even before. Y equals x minus 1 is a simple line that goes through, you know, y equals mx plus b, slope is 1, intercept's negative 1, boom, there's that. If I go over to 1, if I say x, then it's 1, and it's going like this, right? It's a line, okay? All right, something like that, it's just a line. What's this y squared? What's this y plus or minus square root? Well, I put the plus or minus there for a reason. Because if you're going to enter this in your calculator, y equals, you have to put in positive square root. So in your calculator, you're going to have to do this. Square root 2x plus 6. And then a third graph, because the first graph's y equals x minus 1. The second graph, I'll number them for you. Look at 1, 2, 3. The third graph has to be negative square root 2x plus 6. How come? Because when you graph a square root, it's a sideways parabola, not a function. Remember, it's a sideways parabola. Not a function. Why is it not a function? Fails the vertical line test. Algebra 1, rearing its ugly head yet again in calculus. Okay, so how are we going to graph this thing? Well, it's going to be a sideways looking parabola. You're going to graph on your Inspire, okay? So what is this going to look like? Well, let's see. I'm telling you over here at -3, there's a spot, and it's going to kind of go like this. It's going to go. And when you graph them, you need to add those sound effects. You got to add them because it's cooler. Okay, so let's take a look. We're trying to find this area. One more. Okay, so the area that's shaded. What was the second thing we did in those other problems? Found the points of intersection. Well, where do these graphs intersect? Oh, I know, there's one right there. Ooh, that's a good one. That's a good intersection point. Oh, here's another one right here. And how did we do this? Well, didn't we do this? The integral of the top function minus the bottom function, dx. And remember, it was left boundary to right boundary. Look at that picture. And if you were a little lazy to do it on your Inspire, you're just watching, laying in your bed watching this, laying on your couch, whatever, hiding in your room because if you go out to the living room, your parents will give you something to do. If you're looking at this, I hope that you see, you're looking at this and you're like, now wait a minute. The top minus bottom, that part's kind of cool. It is. That's okay. If I do top minus bottom, the top is the square root of 2x plus 6. The bottom is x minus 1. But here's the issue. When I go left to right, if I go left, you know what left is? It only goes over to here. That's a problem. Because sometimes in these weird looking bounded area problems, we don't have, the left isn't all the way over there. So if we do it this way, if we go left to right, we are missing all of this area here. See this area right here? Boom. All that, I'll shade that even darker. All this really dark shaded area, if we did it this way, we miss it. And there's no way to capture it because we don't have a point of intersection over there. This becomes a problem. That's where the y-axis switch is going to come into play. So I'm going to leave that written there because we're still going to do that. But what we're going to do is we're going to rotate this. So here's what we're going to do. I'm going to rotate this, and I want you to look at it like that. Now look at that picture. Left to right, top minus bottom. Now we capture the whole area. But to do that, the problem is, let's see, this was the x-axis and this one was the y-axis. So now, instead of that dx at the end, we got to put a dy, which means we have to change our initial graphs, our initial functions into y functions instead of x functions. Okay? So that's the basic logic that I want you to see about this method. All we're going to do, oh, and in case you're wondering what's behind here, boom. Dartboard, pretty cool. Anyway, okay, so we got to catch that. Look at it sideways. Seriously, just turn your phone sideways and you'll see it. Just lock your screen, just turn it, you'll see it. Because I know you're probably all just sitting there looking at it on your phones anyway. Okay, so what do we have to do? Well, we're still going to do this. So let's set this thing up. I need this point. I need this point. Find them on your Inspire. Use a YouTube video that I uplinked. Okay? I will tell you what those points are. This point is 5, 4. This coordinate is -1, -2. Okay? So, if we're going to go left to right, okay, now remember, this is going to be a y value because it's the y-axis switch. That's going to be left to right. So, let's see, left to right, we're going to go we're going to go -2 to 4. All right? All right? So what's going to be on top? Y plus 1. Now I know it may not look like left to right, but it still has to go small to big. So -2 to 4. If you get this mixed up, the only thing that's going to happen, no one's going to come to your house and beat you or take you to jail. The only thing that's going to happen is your answer is going to be negative. And areas can't be negative, can they? So if you get a negative answer, it just means you either inverted these two or you inverted the functions. So now we have to put here, we need a top minus a bottom, and it's got to be a dy. So that means they have to be y's. We can't put x's in there. Can't put x's in there. So what's the top function? If we're looking at this sideways, the top function was y equals x minus 1. So now we have to do this. Okay, let me change to blue here so you can see that this is a little bit of side work. Okay, y equals x minus 1. Solve it for x. Solve it for x. Y equals x minus 1. Solve it for x. x equals y plus 1. Boom. Y plus 1. What about the other one? Hey, we already had it there. Y squared equals 2x plus 6. Y squared equals 2x plus 6. Let's solve that for x. Well, that's simple. Bring the 6 over. Divide by 2. All of you can do that because you're all awesome. Boom, there it is. Y squared minus 6 over 2. Put in a parenthesis. Okay? All right? I hope you're with me. Hope you're with me. All right. Let me erase this so I have some space. All I did was solve for x. If you need to go back and re-watch that a few times, maybe watch the whole video a few times, okay? You can do that. Okay, let's start putting together this integral. Let's start finishing this. Let's start finishing this. Now we're going to actually do some, folks, everything we did so far was algebra. Now we're going to actually do some calculus. Okay, y plus 1 minus y squared over 2 minus times a minus is a plus. What's 6 over 2? 3. Integral from -2 to 4 dy. Okay? Okay? You see anything we can simplify? Well, guess what? That and that. So let me continue here. The integral from -2 to 4. Y plus 1 plus 3 is 4. Y plus 4 minus y squared over 2 dy. Look at that. Simple little integral. You could have did that the second week of February probably and plugged it in and got it right. That's what this whole problem boils down to. Now I understand that most of your questions are going to be with this whole y-axis switch thing. Calm down, okay? Because I know some of you are going to get all flustered and you're like, this is so hard, and just relax. We're not going to do many of these, okay? We're just going to do just a few to get a taste, and when you do the quiz or whatever you want to call it, a graded work or whatever, you're only going to do 1 or 2 of them, and I'm going to keep them easy. You know me, okay? So let's actually do some calculus here. What's the integral of y? Y squared over 2 plus the integral of 4y, minus y squared over 2. That the integral is going to be y cubed over 3, but there's already 2 there, so it's going to be y cubed over 6. Evaluate from -2 to 4. Okay? Going to evaluate from -2 to 4. I'm not going to bore you with the plugging and chugging because I know that you can finish that part. So try that part on your own, and I'm going to tell you that when you plug all this in, you should get 18. Okay? You should get 18. So plug all that in. Y squared plus 4y minus y cubed over 6. Plug in the 4 everywhere. Subtract. Plug in the -2 everywhere. What do I always tell you to be careful of? What do I always say? Be careful of what? The signs. Right, those signs will always come back and bite you in the butt every single time. So be careful. Alright, so here it is. Area between two curves, part 2. The y-axis switch. So we're going to pull the old switcheroo. We're going to rotate it. It probably, the first time you look at it, you're like, I'm not so sure. I kind of get what he's saying. We're missing that part, but I don't like this switching stuff. I'm going to upload a few problems for you, have you do a few more problems, and maybe in a few days, you try a few on your own. It won't be so bad. Anyway, until next time, folks, until the next time we see each other, take care, be safe, and we'll see you.